Welcome to another session of structural analysis. So today we'll see another problem related to moment distribution method. Okay, copy down the question. Analyze the continuous beam shown in figure using moment distribution method. The beam is given as like this. This is 4 meter and this is 1.5 I. We have a point load of 30 kilonewton. This is 2 meter. Then we have a 6 meter span and it is I, and the load acting on this beam is 45 kilonewton at a distance of 4 meters. Okay. And here also we have a simply support, and this one is 4 meter and this is 2I. So 5 kilonewton per meter. So the beam is given like this. A long beam is given in the question. So before solving, I'll name this as point A, B, then C and D. Previously we were having only A, B, C. Now it is A, B, C and D. Okay. Now we have to solve this one by one. We have to first calculate the fixed end moment for this particular beam, then we have to calculate distribution factor. After that, moment distribution table. Finally here we will get moments. So before that, we will calculate fixed end moments. So fixed end moment is MF AB. Can you tell me what is the formula for MF AB? Minus WL square by 12, isn't it? So minus, what is the value of W? 5 into L is 4 square divided by 12. Tell me the value. 6.66 kilonewton meter. Now what about MF BA plus WL square by 12? So plus 5 into 4 square divided by 12, which is equal to plus 6.66 kilonewton meter. Okay. Next we have MF BC. AB and BA both are over. We'll go for BC. What about MF BC? Minus WA B square by L square. So minus W is how much? 45 into A is 4. What about this one? So this one should be more, no? 1 minute. So I have drawn very close. So this is 45 kilonewton, okay? So this should be 2 meter. Now 45 into 4 into 2 square divided by 6 square. Tell me the value. 20 minus 20 kilonewton meter. Now what about MF CB plus W A square B by L square. So plus 45 into 4 square into 2 divided by 6 square. Tell me the value. 40 kilonewton meter. So AB, BA, BC and CB is over. We will go for CD. Okay. MF CD is equal to how much? Minus WL by 8 central point load. So minus W minus 30 into 4 divided by 8. How much? 4 3s are 12. 120 by 8. 15. Minus 15 kilonewton meter. Then MF BC is equal to plus WL by 8. So plus 30 into 4 by 8, which is equal to plus 15 kilonewton meter. So we have calculated all the fixed end moments. Okay. Now we'll go for distribution factor. Copy down. So now we'll go for distribution factor. Very carefully you see here how to calculate distribution factor for this type of beam, since we have 2 spans, sorry 4 spans totally, right? AB, BC, 3 spans. So distribution factor. So the table will be, we have joint, then member, then relative stiffness, then we have total relative stiffness, then distribution factor, isn't it? So this is denoted by K, this is sigma K and K by sigma K. Okay. Now you tell me how many joints we have here? 2 joints, isn't it? Member AB and BC are connected to one joint, that is B. Similarly, joint C, we have BC and CD, 2 members getting connected at one point. So I will write here, joint is B. How many members are getting connected to joint B? BA and BC. Okay. Next, you tell me what is the next joint we have? C. How many members are connected to joint C? CB and CD. Okay. Now we'll see relative stiffness. Very carefully observe here. See here, we are calculating relative stiffness for BA. See B to A, 3I by 4L. Why? Because it is simply support. So I am writing here 3I by 4L. What about BC? BC again simply support, but we have one more support here. What is there? We have one more support after simply support. So what will be the relative stiffness for BC? It will be I by L only. Okay. When we have simply support, but after that we have one more support, fixed support or simply support, whatever it may be, there is one extra support there. So that at that particular point, what we'll do? We'll take I by L only. But since here we do not have any further supports, so that at that particular point we'll take 3I by 4L only. Okay. So this is over, 3I by 4L and I by L. Now we'll go for CB and CD. See here, see from C to B, it is simply support. But if you see beyond B, we have one more support. So then I by L only. Okay. I by L. Don't take 3I by 4L. When it is extreme corner, then only it is 3I by 4L. Okay. After that, if you are taking for the CB, we have one support here. That is why it will be again I by L only. Now what about CD? I by L. Able to understand? Many students will have confusion, especially in this case. Sir, we have simply support here. We are calculating C to B, we have simply support, but we have one support here. So we consider that support as fixed support only. Okay. So 3I by 4L for span BA. For span BA, I is how much? 2I. So 3 into 2I divided by 4. L is how much? 4. Tell me the value. 6 by 16. 6 divided by 16. 0.375 I. Okay. Now what is I by L for span BC? I by 6. How much? 0.166 I. Able to understand? Now here for span CB, again I by L. So I by 6, which is equal to 0.166 I. What about CD? I by L. So 1.5 I by L, isn't it? 1.5 I by 4. 0.375 I. Now here sigma K. So add these two terms only, don't add all the terms. 0.375 plus 0.166. How much? 0.541 I. Okay. This one is also same, no? 0.541 I. Now 0.375 I divided by 0.4541. 0.693. What about 1.166 divided by 0.4541? 0.306. Right? Next, this one will be 0.306 and this one will be 0.693. Okay. Once you add these two terms, you should get 1. 6 plus 3, 9, 9, 9, 9, 0.999, isn't it?
Yes.
Or here also you will get 0.999. So we got the distribution factors for joint BA, BC, then CB and CD. Now we will go for the distribution table. Okay. Copy down this one. The moment distribution table. So moment distribution table is again important. So what I will do, I will remove this beam, okay, because we need board, complete board for solving. So distribution table will be in this form, isn't it? We have a simply support here, then we have we have a fixed point over there, then we have one more point over here and one more point over here. So this is A, B, C and D, isn't it? Here we have simply support, here also we have simply support, and here also simply support. So now tell me, what is the first step we do? Fixed end moments or distribution factors? Distribution factors. So first write the distribution factors. What is the distribution factor for BA? 0.693. This is one distribution factor. What about BC? 0.30. So this is another distribution factor we got. Next here for span CB 0.306 and 0.693 for this one. So these are the distribution factors. Okay. Next we have fixed end moments. What are the fixed end moments we have? We have calculated minus 6.66 plus 6.66 minus 20 plus 40 minus 15 plus 15. These are what? Fixed end moments. Able to understand? Right. Now in the beam we have simply support at one corner, isn't it? Which corner? In the extreme left side, isn't it? So here moment should be 0. We have to make this moment as 0. So what I will do now here? I will first make it 0. So plus 6.66. Since I have added moment, what I will do? 50% of this one, that is 3.33 I will add here. What about here? Shall I add here? No need of adding over here. No need of adding here. Here also. So since it is fixed support, no need to make 0 here. Okay. Now you add all the terms. This is 0, 9.99, 9.99, minus 20, plus 40, minus 15, then plus 15. Okay. Now carefully observe here now. We have here 9.9 and we have to balance two places at two places. Here also we have to balance, here also we have to balance, isn't it? Why? Because here also we have simply support. These two values should be same but in opposite sign, then only the moment will be 0. Here also both the signs should be, both the values should be same but signs should be opposite, isn't it? So here we have 9.99 minus 20. 9.99 minus 20 is how much? Minus 10.01. Now this minus 10.01 I will make it as plus. So 10.01 into distribution factor. This is 6.936. Okay. Again 10.01 into the respective distribution factor. 8. How much? 3.063. Okay. Now here we'll balance here. Okay. So 40 minus 15 is how much? 25. 25. So 40 minus plus 25 you got, right? So change the sign, minus 25. Minus 25 into 0.306. Minus 7.65. What about this one? Minus 25 into 0.693. Minus 325. Okay, till here any doubts? No doubts. Okay, so what we have done here, we have balanced this equation, right? Balanced this one. So I'll write here balancing. Okay, next, do we have balancing here? No need of balancing over there. Then here also no need of balancing here. Okay, after balancing, what is the next step? Carry over moment. Okay, COM, that is carry over moment. So carry over moment, either you can draw a line or do that, or else after balancing you draw a line over here like this. Okay, now you take down the values. So shall I send this value to this point? No. Why? Because simply support. I can send this value. Okay, so it is 0 over here. What about this one? Shall I take this value? Yes, isn't it? So minus 7.65 divided by 2 is how much? 2.8? 3.8. Okay, 3 point minus 3.8, only 3.825. 3.825. Then here take this value here. 1.531. Okay, yes. Now we can take this value and we can send this value also. That is 0. What about this one? 8 point minus 8.662. So this step is carry over moment. Okay. Now see here, whether we got 0 here in the previous problems, we were getting 0, right? Here both the values were 0. Here also both the values were 0. But here it is not 0, isn't it? So what I will do, I will balance it again. What I am doing now? I will balance again. So that is 0 minus 3.825 is how much? 0 minus 3.825 only. So 3.825. We have added this one. Okay. So it is minus. So what it will become? It will become plus. So plus 3.825 plus 3.825 into 0.693. Tell me the value. 2.650. Next. Tell me. 3.825 into 0.306. 1.17. Okay. Next, we will balance here now. 1.531 plus 0 is 1.531. 1.531. Make it minus and multiply with the respective distribution factors. Minus 0.46. Next. 1. Minus 1.06. Okay. Now do we have to balance here? No balancing. Either you put a 0 or dash. Here also, do we need any balancing over here? No need of balancing over here. So this step is your balancing. After balancing, you draw the line for the simplification. You draw the line and carry over moments. Okay. Shall I send this value here? No, I can share this value. 0. What about this one? 0.46 divided by 2 is 0. Minus 0.23. Then here 1.17 divided by 2 is 0.585. Okay. What about this one? 0 and this one? Minus 1.06 divided by 2 is 0.50. 0. Minus 0.53. Able to understand? See, after carryover moment we are reducing, isn't it? Every carryover moment, see, it was here 3.825, here we got 0.23. We are cutting down the variations, isn't it? So the difference is getting reduced here. Here also it is point. In the next step, hopefully we will get 0, 0. Okay. So now again what I will do now? I will do balancing. So 0 minus 0.23 is how much? Minus 0.23. Minus 0.23 will make it as plus. Okay. So plus 0.23 into 0.693. How much? 0.159. Next value again 0.23 into 0. How much? 0.070. 0.07, right? No need of 0 writing here. 0.07. Next here 0.585 plus 0 is 0.585. You make it minus. So minus 0.585 into 0.306. Minus 0.17. Next. minus 0.40. So again here no need to do any balancing at the corner. Okay. Now after completion of this balancing, draw the line and carry over moment. So I cannot send this value here. So it is 0 here. So minus 0.17 divided by 2 is how much? Minus 0.085. Next here I have taken this value here. I will send this value here. Okay. So 0.035. Here also it is 0 minus 0.2. Okay. So this is carry over moment. So see here we got 0.0. Okay. Here we got 0.0. Okay. It's almost equal to 0 only, right? So what we'll do now? We'll try to add the values. Okay. 0.08 or 0.8?
Minus 0.4.
Which one? Correct, no? So now you add all the values. So once you get 0.00 over here, so 0.00 here, then we can stop. So what will happen? The value will vary small. This value and this value, whatever the values, it will vary small amount. If you want, you can go further also. It's up to you. Okay. So now you start adding. So from where you will add? From here you should add all the values. Okay. 9.99, 6.936, 2.60, all these values you add, you will get the value of this one. So this is capital MAB. What about this value? Start adding from here. 19.735. Next. Minus 20, all these values you add. How much?
Minus 19.80.
Minus 19.80. So this is MBA and MBC. Now you add these values from 40. 33.87. What about next value? Quickly. Last one is? This is MDC. What about this value? Somewhere around 33 something you will get, minus 33. Minus 33.78. This is MCB and this is MCD. Okay, able to understand? So this is how we calculate all the final moments using moment distribution method. Okay, this may be, you can expect this problem for 10 marks in your final examinations. Okay, so how to make it 0? Like this. Okay, how we got the 0.23? How we got this value 0.23? We got the value of 0.23 by dividing this 0.46. How we got this 0.46? Can you tell me? By 1.531, by balancing, isn't it? So add this one, whatever the value you will get, multiply with the respective distribution factor, you will get the value of this one. Okay. How we got this 1.531? By dividing it. How we got this value? By balancing this one. Okay, all the things should be there in your mind. Once you open the big book before final examination, you will not able to understand how we got this table, because there is no sort of equations, no sort of method. You have to understand by taking out the moments and the respective distribution factors. Okay, so if you open after 1 month and you see this table, you will not understand. Okay, so the thing is, you have to practice, you have to understand at the time of practicing itself. Okay, copy down.